if they're in a low enough orbit, the atmosphere, gravity eventually pulls them back into the atmosphere, they burn up, so we don't get to see them again. We actually did have some satellites that were on the launch that Alex mentioned back in October, where the rocket exploded on liftoff. 8 of those satellites, surprisingly, were survived in their containers. So those satellites were bouncing around in the ocean. They sent them back to us, and actually several of those satellites we were able to make contact with, which was quite surprising given that they were in a rocket that exploded. But typically, no, we don't see the satellites again once we launch them. They stay in space until they come back down again, and then they burn up.
Hey guys, I hope everyone is fully caffeinated for the last part of our presentation. So I just wanted to emphasize that this Mosaic browser. So MapPoint Asia already has access to this and are using it, and as I mentioned, it's designed for kind of all levels of user to come and engage with our imagery. So if you guys want to have a play around with this, please come and see Ed and Ty at MapPoint Asia. We think you'll be impressed with what you see. I wanted to take a few minutes just to talk about how we make the mosaic you see here. So traditionally when mosaics are made, and a mosaic is taking different types of satellite imagery and putting them together to create a contiguous uniform image. Because obviously one picture is less useful on its own and more useful when combined with many images. So typically how that happens is actually a bit like the carpet down here. You take one picture and you put it together with another and you sew it together. And it creates somewhat ugly, non-uniform images. So as Bo showed you when we zoomed into Thailand, there's a picture from one camera, a picture from another, and you can't really see what's going on. So what we have developed is a pretty innovative way of putting these images together. And we call it pixel compositing. Now, we've actually open sourced the code behind the pixel compositor. And what it does is it looks through every picture we've ever taken and finds the best specific pixel for every place on the planet, and then puts those together in one uniform image. So this allows us to basically take away the clouds, remove poor quality imagery, but more importantly, give you a uniform image of all of Thailand. So let me just show you what that looks like. We have a lot of cameras in space, and every time we take a picture, it looks a little bit different. And that's normally because the atmosphere is a little bit different. There's clouds, there's water vapor, so every single image we bring down, when we pick the best pixel from it, you see this kind of non-uniform, slightly messy, less visually useful or appealing image, composite picture. So this is what we have to deal with after we've picked each pixel. And the way we deal with it is through a process we call radiometric normalization. So what we do is we look at other sensors in space, be that Landsat or kind of other government sensors looking at the atmosphere, and we try to correct every pixel we have captured to a uniform standardized data set. What that allows us to do is create an image that looks like this. So I'm just going to go back and forward a couple of times here. That's after we've picked every pixel that we would like to pick. This is after we've normalized them to create a uniform image. So this is what we are presenting to you and to MapPoint Asia through the Mosaic browser. And it's not that interesting to do that on one pixel or one image, but once you start doing that on millions of images, you move from this type of mosaic, which looks decidedly non-uniform and is just an artifact of operating tens and hundreds of cameras in space, to something that looks like this. And so if we go backwards and forwards, you will see that this now appears to be a uniform picture of most of China and most of South Asia. Again, this imagery was captured very quickly in the space of 3 months. And using these advanced techniques in cloud storage solutions, we can basically reprocess that to a degree that creates a very usable, large, broad mosaic for people like you guys. So I just want to go in a little bit of detail here. It's kind of technical once we go too far under the hood. So I'll stop there. but I just wanted to give more of a feel for the products you will see in our browser tools. And we're going to shift gears a little bit now to just try and demonstrate how this imagery is useful to you now. So we are building our constellation, but we already have 24 satellites operating. And Bo is going to walk through some things that we've spotted in the last few days that we think will be of significant value to people in Thailand.
And before I do that, I think I'd like to emphasize that this amount of data over Thailand and parts of South Asia was collected only with about 20% of the number of satellites that we'll have on orbit by the end of this year. So right now, over the past 3 or 4 months, this has been collected with about 24 satellites. We have over 100 satellites scheduled to be launched throughout the rest of this year and early 2016. Essentially what that means is this mosaic or this map of South Asia will fill in and we'll have a complete map, but then we'll have the ability to update that map very, very frequently. And the way that we make this data available through a standard web browser is you can say, eventually the end of this year, early next year, show me all of the data of this particular region of Thailand that was collected within the last month. And you will be able to see a monthly mosaic of a region, or a quarterly or a seasonal mosaic of the region. So that is the capability that we're building. This is just a very beginning of the capability. So I just want you to bear in mind that this is what we might call an alpha product. By the end of the year, we'll have a full mosaic of this region that you can begin to use and interact with. So I want to make this a little bit interactive. There are a number of what I call applications or use cases. So these images are quite interesting, but of course an interesting picture doesn't really help us unless we're able to do something with it to extract information from the picture. So the first example I wanted to show you is in agriculture, and this is a very interesting capability that we are building. This image, a little bit dark, this was captured with one of our very early test satellites on October 13th in China. This area is about 100 square kilometers. You see a number of agricultural fields in the area. 10 days later, if we look at this same region, visually, our eyes can detect what was harvested, where it was harvested. That's a qualitative piece of information that we can intuitively see with our eye. But using automated tools, those of you who have used remote sensing software or data mining algorithms allow you to basically compare two images from two different dates and identify the exact locations of fields that were harvested. Of course, the fact that this information is geospatial in nature means that we can take estimates on the size of the fields harvested. Again, when we have more satellites in orbit, we will be able to do this at very small time intervals. So you could do a weekly assessment of agriculture harvest or a weekly assessment of crops that have been planted. That is a very useful tool at all levels of government, at a highest level for food security, but also practical levels, understanding what is harvested and where it is harvested. We talk about water. There's lots of water in the region, and some interesting things. And we'll start with more of an industrial application. We'll move to other applications. This just gives you a sense of the type of information that you can see. Of course, ports are very active locations. There's traffic coming in, there's traffic going out. It's often useful to understand what's going on in terms of what is being loaded onto ships, what is the condition, what's being stored on the port. If we look at a couple of just interesting spots in this image, again, this is an image that is 3-meter resolution. Oftentimes when I tell people that we are collecting at 3 meters, they think, oh, that's a low spatial resolution. I can't see a lot of details. But just being able to identify, doesn't show up terribly well on the screen, but those two arrows on the left-hand side, we can see iron ore that's piled and ready to be loaded onto ships. On the right-hand side of the arrow, we can see coal that's ready to be loaded on a ship. Of course, this is, again, more than just a picture. This is geospatial information, so I can estimate the amount in terms of measuring the size of the piles. And with someone who understands